Quantum physics is perhaps the most successful theory in the history of science. But do you know about the principles that form the foundation of quantum theory itself? The 6 principles that we will cover in this video are different from any other theorem, relation, or equation of quantum physics. These 6 principles aren't derived from anything, but rather the rest of quantum physics is derived from these fundamental principles, or postulates as they are called. In this video, we'll explore what a postulate is, and I'll also give you a brief overview of all 6 postulates and a neat little memory trick to remember them. Sounds cool? Then let's get into it. Okay, so what exactly is a postulate? The Cambridge Dictionary defines it as an idea accepted as a basic principle before further ideas are developed from it. You see, any logical system needs a starting point, and that is exactly what a postulate is. It's a foundation for your logical structures of laws and theorems. It's not derived from anything else, it's the foundation itself. You can't ask where does this postulate come from. Rather, it is the starting point of your reasoning. But then, can any statement be a postulate? Technically, yes, but it wouldn't be useful unless it describes our reality. In physics, we choose postulates that help us build theories that are aligned with our observations. One good way of picking useful postulates is based on experimental results. In fact, this is something Einstein did in his postulates for special relativity. Another way of picking postulates is to have something that sounds reasonable and pick that as a postulate. And then you can cross-check the theory that follows from this postulate with the physical observations. Lastly, your postulate can also be something that's really obvious, like say, the fact that fire is hot. I bet this was a popular postulate in the Stone Age, but not so much in modern physics. Now let me warn you, the postulates of quantum mechanics may sometimes seem like they have been pulled out of thin air, but actually, they're just expressing the behavior of the quantum world as observed in our experiments. The challenge in understanding these postulates lies in the fact that this behavior of the quantum world is encoded in an abstract mathematical language, and understanding the connection between the math and physical principles requires mathematical maturity, which can only develop over time. So when watching this series, I recommend focusing on what each postulate actually states without really worrying too much about why a particular equation or a mathematical concept is being used there. Later, it'll all start becoming clearer as you start to use these postulates in practice. In the next video, we'll go through the wave function postulate. There, we will understand the concept of the wave function and explore some of its properties. In the second video, we'll talk about the operator postulate. This postulate tells how physical quantities like energy, position, and momentum are represented in quantum physics. The measurement postulate describes how a quantum system changes upon its measurement, while the expectation value postulate lets us find the expectation value of physically observable quantities. The fifth postulate of quantum mechanics is about the Schrödinger equation, which is perhaps the most important equation in quantum physics. And the last postulate of quantum mechanics describes the properties of a quantum system comprising of multiple particles. And yes, there are many postulates and it's difficult to remember all of them. But here's a trick. All you need to remember is that quantum mechanics is a mess of waves and operators. And that's how you can remember the names of all 6 postulates. Now, if you also want to remember and understand what each of them mean, then make sure to subscribe to the World of Quantum and remember to hit the bell icon. That way, you'll be notified when the video for each postulate is published. In this series, I'll expect you to know some basic math. You must know what integration and derivation is. It will also be beneficial for you to know what linear operators, vector spaces and inner product spaces are. But if not, that's okay too, because I'll briefly touch upon these last 3 concepts in this video series. I hope you're excited to learn about the foundations of quantum mechanics. Anyways, I'll see you in the next one. Thanks for watching.